A very good morning to Doctor and my teammates. Today we are going to present our centrifugal pump design. First of all, I would like to present to you my fellow teammates. They are Lam and Chua. We are from A&A Pump Company, I'm Lam. Recently, we received a consultation project for centrifugal pump design of a hygienic product processing plant. The management requests our team to increase the fluid flow rate by 25% or more. So in the following presentation, we will present to you how are we going to select the most suitable pump to fulfill the plant management requirement. So first of all, what is a centrifugal pump? It is a mechanical device designed to move a fluid by means of the transfer of rotational energy from one or more driven rotors called impellers. So how does a centrifugal pump work? First, the fluid will enter the impeller at its axis and exit along the circumference between the vanes. Then the rotational motion of the impeller accelerates the fluid out through the impeller vanes into the pump casing. Lastly, in the volute casing, effectively creating a curved funnel with an increasing cross-sectional area towards the pump outlet. This design causes the fluid pressure to increase towards the outlet. So, what is a self-priming pump then? Self-priming pump is a type of centrifugal pump. While air is the main enemy of the standard centrifugal pump, when the standard centrifugal pump encounters air, it becomes air-bounded. So when the air binds the pump can no longer force the water out. Hence, the pump becomes not efficient. Self-priming pump can effectively eliminate this problem. Self-priming pump is able to evacuate air from the suction side at the startup before commencing its normal pumping mode. Hence, a self-priming pump is considered more efficient. So why do we choose self-priming pump over the normal centrifugal pump? There are several reasons. First, it is easier to build up and maintain or repair. Self-priming pump is mounted above the liquid source, hence less infrastructure is required to set them up. It is capable of evacuating air from the pump suction line without any external auxiliary devices. It can also reduce the construction and equipment expenses since the priming system is mostly a non-wet component and it does not need expensive construction materials. Thirdly, it can maximize the efficiency of the pump at reduced power requirement. Lastly, self-priming pump is able to handle solid. Some self-priming pump can handle solid up to 3 inches. Thank you, that's my part, and I'll pass to my teammate next.
Thank you, Lam. I am Chuang, so I will discuss about the selection process of the pump. So our project, we will focus on the self-priming pump only. From this table, we can know that we have 4 self-priming pumps. First, I will discuss of the first self-priming pump, which is TPS 2030 2-pole 50 Hz. This is the graph for this pump, and we required flow head is 44.66. So we know that which is out of the range, so we unable to get the impeller diameter. So this pump will be rejected. And next, I will talking about the second pump, which is TPS 3050 2-pole 50 Hz. Our required flow head is 44.66 meter, and the minimum required for flow rate is 30. So the red arrow will be indicate minimum parameter, and the green arrow will be indicate the maximum parameter. Okay, from this table, we can know that the maximum efficiency of this pump is 44%. And this pump will require 12.5 kilowatts, but we must plus the safety factor. So this pump will require at least 13.125 kilowatt. So I will select the next largest size standard motors, which is 15 kilowatts. And this pump is suitable for this application. Next, the third pump is TPS 2030 2-pole 60 Hz. This is the graph for this pump. And next, we can know that this pump, the maximum flow rate we just get is 22, which is not fulfill the requirement for the plant management that need to increase the flow rate more than 30. So this pump is not suitable to be used. Next, the fourth self-priming pump is 3050 2-pole 60 Hz. The minimum required flow rate is same 30 and the flow head is 44.66, and we can know that the red arrow is indicate the minimum parameter and the green arrow is indicate the maximum parameter. Okay, from this table we can know that the maximum efficiency of this pump is 40%. And this pump will require 13 kilowatt, but we must plus the safety factor so that this pump should be at least 13.65 kilowatt. So I will select the next largest size standard motor, which is 15 kilowatt. And this pump is the suitable for this application. From 4 self-priming pump, we can come to a conclusion that we can get 2 pump just have the data, which is TPS 3050, 2-pole 50 Hz, and another one is 2-pole 60 Hz. But 2-pole 50 Hz have the higher efficiency than 2-pole 60 Hz. So we will select TPS 3050, 2-pole 50 Hz is the most suitable pump for plants management requirement. So that's all for me. Thank you. Next, I will pass to my teammate.
Thank you, Chua. Now, I'm going to present about the selection of the electric motor. The power of the pump need to be used is 15 kilowatt. Therefore, the motor that we will use is IEC 132M motor. So basically, this is the image of IEC 132M motor. Specification of the IEC 132M motor. So this is the 6th specification of IEC 132M motor. The first one is the type of phase used is 3-phase induction motor. Second, the type of voltage used is voltage 3-phase 400 volt plus minus 5%. Third one, the type of enclosure used is IP55. Fourth, the class of insulation is ISO class F. Fifth, the type of duty is IMB35. Sixth, the type of cooling is IE3. This is the standard dimension of IEC 132M motor. Cost of the centrifugal pump and IEC 132M motor. Here is a breakdown of how much the pump and motor cost in a year. For annual power cost, it costs $70,669, and for initial purchase price of motor, it costs $10,000. To fulfill the requirement of the plant management, that is to increase the fluid beverage flow rate by 25% or more, our team has come to a conclusion that the TPS 3050 2-pole 50 Hz is the most suitable pump to be used. The centrifugal pump that is selected needs a motor power of 15 kW to be generated. Therefore, the electric motor that is selected is IEC 132M motor. The initial purchase price is slightly $10,000. That's all from our group. Thank you for your attention.